So the lesson that we're going to take a look at now is dealing with something that's called cosine law. In the last lesson, we looked at what was sine law and how can we use sine law to determine angles and sides of triangles which do not have a right angle. Cosine law is something slightly different, but also helps us to do the same thing, find angles and sides of triangles that do not have a right angle. Now, there are some limitations to sine law. If we were to be given all three sides of a triangle, we would not actually be able to solve for an angle using sine law because we only have one piece of information per ratio on this. And that's the case where, or if we have an angle that is surrounded by two sides, we can't actually use that in sine law because again, we only have one piece of information per ratio. So let's go through a little bit of review here. Every triangle has three sides and three angles to it. Okay, so we have three sides and three angles. We have 6 parts to each triangle. Now, in a right angle triangle, we already knew one of the angles, and so we only had to, we knew that 90-degree angle, so we only had to determine what two other pieces were, an angle and a side or two sides. In a non-right angle triangle, we actually need to know at least 3 parts of this here. So if we know at least 3 parts of it, so we know at least one side and any 2 of the other 5 parts, we can use law of sines or law of cosines to solve for any of the other pieces in our triangle. So let's go through the sine law just as a quick little bit of review here. Remember that sine law is sine A over little a is equal to sine B over little b, which is equal to sine C over little c. So when we have a triangle that we're trying to solve, we need to know at least one complete ratio. So we have to know at least an angle and a side which are related to each other. Once we know that, we can then solve for any of the other pieces in that triangle. Now, the problem becomes if we only have one or we have all 3 sides, we don't have a complete ratio. Or if we have, let's say we have sine A and we have little b and little c, okay, we don't have a complete ratio. And we can't actually go through this using sine law to solve for little a, nor can we find big B or angle B and angle C at the same time. Thus, we cannot solve a triangle if we're given those pieces of information. That is where cosine law comes into play. Cosine law deals with cos as well as a variation of the Pythagorean theorem. Now, I'm not going to go through the proof of how cosine works like I did with sine law. It's a little bit more complicated, and we're not going to go through it. But we're just going to say this is what cosine law is, and this is how we're going to use it. So cosine law, we have 3 different variations. They're all the same thing, they just deal with different angles and sides. This is cosine law. I'm just going to highlight our 3 here. Okay, so this is the first one here. A squared is equal to b squared plus c squared minus 2bc times cos of a. That's the first one. The second one is very similar. We just switch around some of the letters. So here now we're going to start with b squared in the front, and we have a squared and c squared. And then instead of bc, we have ac, and here we have cos b. And finally, try to get a different color in here, we have the one that is involving c squared out in the front, and b squared and a squared are in there, b and a are here, and cos c is right there. So there are 3 different versions of cosine law. They're all 3 exactly the same, minus the letters that are in specific places. Okay, so that's cosine law, and we're going to go through in a little bit of how to use it. But first, I want to show you what the 3 or how when we use each one of them. So first things first, before we get into any of these here, if we have a right angle in that in a triangle, we can use our trig ratios, sine, cos, and tan. We did that in grade 10. We did a little bit of review already in grade 11. And so you have that idea as to how to use trig ratios to solve right angle triangles. If we don't have a right angle triangle, then we need to make sure that we have at least 3 pieces of information to solve for everything else. So here's a bunch of situations that we could have, and I'm going to try to draw them out as best as possible using some triangles here. All right, so first case scenario. Let's say that we have the 3 sides. I'm just going to try to tweak this a little bit so we definitely have 3 unique sides here. Okay, so if we have 3 sides to this triangle here, and I'm just going to, instead of labeling them with numbers, I would often label them with numbers. Let's say we have A, we have B, and we have C. Okay, so if we have A, B, and C, and I'm going to ask you to solve for what is theta. Okay, so if I'm asking you to solve for what is theta and I've given you A, B, and C, we need to use the law of cosines. Okay, and this is a new one that we just looked at, but if we have all 3 sides, the only way we can solve for an angle is using law of cosines. We can think of this as well as being a side, side, side triangle. And I'm just going to put a little abbreviation here. S is equal to a side, and A is going to equal to an angle. So in this case here, we have 3 sides to a triangle. So an SSS, that would be, we would use law of cosines every single time in that case. Now what happens if we have a side that has, that is formed, and the angle that is formed by those sides. Okay, so I'm just going to draw out my little triangle here again. And I'm going to try to, again, I don't want to have an isosceles triangle or an equilateral triangle, as that really changes things a lot. So in this case here, let's say that we have A and we have B. I'll put it up on top here. And we know the angle. Okay, so I'm going to put it in purple. Purple is going to be the things that we know. Okay, and so I'm just going to give this angle, I'm going to call that 85 degrees. I'm going to write it in really simple here. Okay, so let's say it's 85 degrees. So we have A and we have B, and we have an angle of 85 degrees. Now that angle is being formed by the 2 sides that we know. It's being formed by A and B. So we might call this a side angle side. Side angle side. So we have the angle that's formed by those 2 sides. Now, there's other cases as well that I'll go through in a little bit, but in this case here, we're again going to use law of cosines. So if we have that interior angle, which we looked at in sine law as us not being able to solve for, we would then be, this is angle C, so to speak, and so we would then have to use angle C to solve for side C. And um, I'm just going to put C in here. Okay, so I'm going to say that we're solving for C. So the red is what we're solving for, purple is what we've gotten. And so C is what we're trying to find here. And we have the side angle side. Therefore, we would actually have to use law of cosines. And again, we're going to go through some practice in just a little bit as to how we solve for that case. Now, let's go back and do a little bit of review again from what we've done in the past. Let's take a look if we have 2 sides and not the angle that is formed by those 2 sides. I'm just going to move my triangle over here a little bit. There we go. Okay, so there is our triangle. So let's say that instead of what we had up here, we're given that this side is A, this side is B, and let's say that we are given angle A. And I'm just going to put big A right there. So if we know angle A, in this case here, we can now solve for angle B. And I'm going to put angle B in here. Okay, B is in red, that's what we're trying to solve for. Okay, so we have side, side, angle. Okay, side, side, angle. In this case here, we would be able to use law of sides. Side, side, angle, SSA. Funny little story, 1 year I was teaching this and I decided to do angle, side, side. That didn't turn out so well. I'll let you determine why that didn't turn out so well. So I had to quickly change it. But so now I do side, side, angle. In this case here. So in this case here, we have a side and an angle which are related. Okay, remember we have A and little a, and so we can then use little b to solve for big B. Once you know big B, we could find big C, and then using big C, we could find little c as well. So we could go through that and we could solve for any one of those. All right, next one here, and one side and an angle that is formed, and 2 angles. Okay, so let's put this in here. Again, I'm going to draw that out a little bit differently here. And so if we have All right, so if we're given, let's say we're given this angle, we're given B, and we're given A, and let's say that we are also given little a right here. Okay, so if we're given little a right here, we can then solve for what is little b. We could also solve for what is angle C, okay, using the property of triangles, and we could use that to solve for little c. But in this case here, we have angle, side. Actually, I'll do side, angle, so SAA or AAS. Okay. In this case here, we have a side and two angles, and anytime we have two angles, we can find the third angle, and because we have one side, we can then use that to solve for any other side using the related angle. Okay, so we can, sorry, this is supposed to be in red. Let's change that. There we go. Okay, so we're trying to find little b here in red. Again, in this case here, we are able to use law of sines to do that. We can put it into our ratios, and we can solve for any one of those pieces. The last one that I want to take a look at is just what happens if we have all three angles. And this is, again, this is a special case, but in the case that we have, let's say, all three angles. So let's say we have big A and we have big B. Again, I'm just putting these in as generics. I would sometimes do the actually give angles, but in this case here, I just want to put in letters. So let's say we have all three angles. We do not have enough information to solve for a side. We must know at least one side before we can solve for any other information. Okay, so we have to know at least one side before we solve for, because we could have a multitude of triangles which have the same angles. Okay, we call them like equivalent triangles. So we could have like a really small one that has the same angles. We could blow it up into a bigger one that has exactly the same angles. We can make a massive one that has exactly the same angles. We need to know what one side length is before we can solve for the other sides. So this is a little breakdown of what law we can use in each case. So number one, remember that if we have a right angle, we can use any of our trig ratios, sine, cos, tan, whichever one. And if that's where you're most comfortable, use those. If we are given any of these other pieces of information here, so if we have all three sides, law of cosines. If we have an angle that's surrounded by two sides, law of cosines. If we have an angle that's not surrounded by two sides, okay, then we're going to use law of sines. If we have two angles, we're going to use law of sines. And if we just have all three angles, okay, so in this case here, we would call this an AAA. We don't have enough information to solve for. So a triangle like this, you know the three angles, that's all the information we can know. Until we know one side, we can't actually solve for anything else.